Go.
Good morning, ladies and gentlemen. Do this now. Draw a circuit diagram using the correct symbols of a battery and bulb with an ammeter and a voltmeter wired in correctly. So go ahead and work on this. Do this. Let's see.
Pause the video and make your diagram.
It says a battery, right?
Yeah.
And a bulb. Okay. And it wants an ammeter in there too, yeah?
Yep.
Okay, so I'll put the ammeter in there. Now it doesn't really matter which side the ammeter is on, as long as it's in the flow. In the flow.
Yep.
Okay, and then for the voltmeter, we'll go ahead and put the voltmeter right there, across the bulb. Okay, I think that's everything, right?
And
Positive and negative side. Okay, and ellipses. If the voltmeter shows 2.7 volts, okay, so now we're talking about 2.7 volts up here, and the ammeter shows 0.25 amps. Okay, what is the power output of this system?
go ahead, boys and girls. Look in you've got your notes right there. What is power?
How do you calculate power? Power is intravenous.
Intravenous.
IV. Intravenous, okay. And so our current, we have our current, yes?
Yes.
So 0.25 amps. So we multiply that by our voltage, which is 2.7 volts. Thank you, Mr. Boykin. Okay. And turn on 0.25. Oh, that's 2, that's an 8. 25 times 2.7, and I get 0.675. Let's call it 0.7. Okay, and what are our units here?
Amp volts?
Okay, amp volts or a
Watt?
or a watt. Now, when we're talking about brightness, we're talking about power.
That's right.
Okay, all right. What did the ammeter do when you turned the battery around, and why? Do we want to show them?
Yeah.
Okay, so here we are.
Get
So-
the voltmeter out.
Okay, we don't care about the voltage right now. Here is our ammeter, and normally we connect the black wire to the black side. This is the negative side, and then this to this side right here.
Okay, first of all, put the
Oops.
bulb in there. Don't just go.
Yeah. Oh, like this.
Yeah.
Wait. Link this in here. That's what you're saying.
So bite the black one onto
Yeah.
the bulb.
Merp, merp, merp. Alligator clip, like this. Okay, black side here. Okay, bada boom. There we go.
Okay, and then turn
Okay.
the battery around.
And what
Whoa.
happens?
The needle goes the other direction.
It goes the other direction. So what happened? Well, we have the needle that goes the other direction like this. And why is that?
Well, the question is, what does an ammeter measure in the first place?
Well, the ammeter is measuring the flow of current, right? And we're talking about electrons traveling through the wire, right?
Yeah.
And so they travel one way. Let me go to my next slide here. What force would an electron in the wire experience next to the battery's negative pole? So this is my negative pole. We have a negative electron. It's being repelled from this side, right?
Yep.
And it's going to be what is it going to experience as with the positive pole? Well, attraction. So repulsion from here. Get me out of here. And attraction over here. Oh yeah, all over here. So we see those electrons flowing in one direction. The ammeter reads that and tells us what's going on. If we flip the battery, now it's just going to read the opposite.
Well, now the electrons are going to flow in the opposite direction
Exactly,
through the
they're
ammeter.
flowing in the opposite direction. So it reads, it's like, from this way to this way, okay, it goes up. If we flip it this way, now they're coming out this way, it goes down
Yep,
and through. Okay, hopefully that's making sense.
I think so.
Okay, and this is the why. We're talking about the force that the electron experiences in the battery. Okay, so why did the voltmeter needle go one way or another depending on how you placed the wires?
Oh.
So now we got a wire in that voltmeter, right?
Now you can just use it on the battery.
Oh, on the battery here? Okay. Yeah. Okay. So here we are. Okay.
Voltmeter goes up.
Do its thing.
And then let's flip the battery around. And now it goes down. So the question again is, what does a voltmeter measure in the first place?
Okay, well, it's measuring the change in electrical potential energy, right?
Right.
Okay, and as we hold it the quote right way, out of the negative here into the positive here. Oops, I'm missing the things altogether. Oops. Oh, I'm holding the wrong way. I'm doing
Get that ammeter out of here.
Yeah. Okay. The delta V, our potential energy difference increases, right? And we see that on here.
It expects to see an increase.
Yeah,
That's right.
It's reading an increase. It's expecting to see an increase.
And it wants to measure how much of an increase.
Yeah.
But if you turn the battery around, it's not seeing an increase, it's seeing a decrease.
Mm-hmm.
So it's a matter of perspective.
Mm-hmm. Yeah, exactly. Matter of perspective. I like that. Okay, so why is each bulb brighter when you put a second battery in the circuit?
And it was. The bulbs got brighter.
Yeah, they got brighter, right?
Well, if you look at your data, what does your data tell you?
Okay, well, our data should tell us that it was brighter when we had 2 batteries because we measured more current.
Measured more current
Okay.
because there was
More voltage.
more voltage.
Right? So and that reminds me over here, okay, why is each bulb brighter? We're talking about brightness, we're talking about power. More current, more voltage, more power.
That's right.
It makes sense. Okay. What is the relation between how bright the bulb is and how much current flows through it?
Well, you can see that from your worksheet. When you went from 1 battery to 2 batteries, did the bulb get brighter?
Yeah, it did.
Yep.
Okay, so more current equals more power equals more bright.
Yes, ma'am.
Right? It all kind of comes down to that understanding that equation over there.
Yep.
Right? If you've got more of this, you're gonna have more of that.
Yes, ma'am.
Okay. So for the same number of batteries, why did the bulb have more current than the other? Oh, because remember
Which bulb had more current?
the round bulb, right?
Yeah.
So the round bulb had more current than the oblong bulb.
Yeah.
What the heck? What's going on, right? And so we have to introduce our handy word, resistance. Okay, so the resistance of a material is how hard it is for current to flow through it.
Yep.
Okay, so with all things being the same number of batteries, it's a light bulb. We are looking at, okay, well, what else factors into it? Resistance, which is just, like resisting something. Oh,
Yeah.
okay, how hard it is for something to
Well,
flow through it.
a thing about resistance is like how hard it is to run through air. You don't think, well, I can run through it, it's no problem. But if you run through water, water has more resistance to your flow.
Oh, yeah.
So,
Ignore that. Ignore the man behind the curtain. Okay. Okay. All right. So how can we calculate resistance? How can we know resistance? Does this look familiar from yesterday's lab?
that's that ratio of volts to amps.
Yeah. And go look at the back of your paper if you don't believe me. And you will see, there it is. Like, where is it? Okay. And you will see volts over potential difference over current. Right there. So we calculated resistance already. And
Let's look at that data again for just a second
yeah.
here. I noticed that the round bulb is like right at 6.9, it's less than 10, and the oblong bulb is up around 30. So the round bulb had less resistance than the oblong bulb.
and what do we get as a result of that?
We get
More bright.
more current flowing through the round bulb, and since there's more current, you're going to get more brightness.
Okay, so how do we keep track of all this information? This equation right here, or if you want to think about it as VER, okay, easier to solve for things there.
Yeah.
But this is Ohm's law, like this. You can,
There's 3 quantities, and this is the relationship between them.
Yeah. And what did we just say, Boykin? We said if there's more, if there's less resistance, there's more current, right?
That's an inverse relation. That's right.
Okay, so here's Ohm's law. Let's talk about units. An ohm is a volt over an ampere.
And this was named after some guy named Ohm,
Ohm.
George Friedrich Ohm, and the symbol is the Greek letter omega. See, that's like a circle with a little feet on it.
It's also like her hairdo. What's her name? Mary Tyler Moore. Not related to Miss Moore.
Nah.
Yeah. Okay. All right. Moving on here. Oh, video. So should we watch this with them together right now, or should we have them pause and go watch below?
Well, boys and girls, you should pause this and watch this video. You know, we'll put here's a link for it.
Yeah, we'll put it right below.
And the question is to stay awake during the video. It's got all kinds of great information in it and explains the physics about what's going on at the microscopic scale that causes resistance.
Ooh, sounds fun.
So let's stop the video right here and watch this video.
It's about 9 minutes long. Okay, and you're back. So now that you know everything about electricity and you're super confident with Ohm's law, let's talk about the mystery bulb challenge. Da-na-na-na. Okay, so
we have a mystery bulb.
we do.
It's different from what we had before, although it's oblong. It's not the same one we had before.
Okay, so what are we gonna do with this?
Say,
Okay. Oh wait, Boykin, did we want them to draw this diagram first, actually?
Well,
down here?
on the lab, notice it asks you to draw a diagram showing all the symbols, no numbers, just the symbols. And it'll look like that, but you won't have these numbers. That's the numbers from the do now. So what we're going to do is on that diagram, if you pause the video, if you don't have that diagram done yet, draw the diagram, and then we're going to give you some data.
Okay, so let me go ahead and draw that diagram real quick so that way I have somewhere to write my data as well. So it's just gonna look something like this. And I'll put my ammeter right there. Boop, 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 boop. And voltmeter goes here. Okay, so, and if you need to, positive, negative sign, because don't forget, that's the bigger side there.
Yep.
Okay, so we need to find the, well, let me set it up here. One battery, Mr. Boykin?
Oh, let's go for 2.
2!
Let's pull out all the stops.
And if you're like, Miss Moore, you gotta make your diagram match. If you're really feeling like, you know, you gotta be on it, add a second battery in there. Okay, here we go. So voltmeter goes across the bulb. We'll make it look like this. Okay, do you guys see that there? The circuit? And then we're gonna plug the black side first. Okay, get on there. Okay.
I have a bicycle that's the same color as your nails.
Oh, what a cute color.
I know.
I almost match here.
It's called Celeste.
Okay, so what are we measuring in? The first thing is the electrical potential difference, right?
Well, all right.
So, is that right? Are we all set up here?
Go.
We all good? And, ooh, nice and bright.
Okay, that's about 2.5 volts.
Okay, so I'm gonna put that right here. I usually leave space in the V for it, but that's fine. 2.5 volts, and then the current, yes. Okay.
And that is 475 milliamps. 475 milliamps, which is how many amperes?
0.475 amperes.
So put this data on your diagram.
Okay.
And then on the worksheet there,
It wants you to, so it also wants you to find the resistance and the power. We can't measure the resistance and the power with the tools that we have, so you need to calculate them.
Yep.
So for homework, wait, actually I think I have a few more slides here. Okay, we'll come back to this.
well, hold up.
no.
They have to connect. So what you're going to be doing, well, you know, we can come back to it. No, I agree.
Do you want to, because wasn't our last slide the homework slide?
This is the homework. I
Yeah,
think.
yeah. Do you want me to just tell them what it is right now, you think?
Well, you're going to have to
Finish your
label
calculations.
the voltage, the current, the direction, the electron flow, show your work for the resistance and the power.
Yeah, I mean, so finishing up those calculations, and then don't forget to show the direction of the electron flow, okay?
Yeah.
We'll repeat this for you guys. All right, so next question for you is, what does the bulb filament do in the first few moments after you connect to the battery?
Let's take the voltmeter off so there's not so many wires here.
Yeah. Okay, so we're looking at what happens to the bulb filament. Okay, so really be paying attention there, guys. Okay, after I in the first few moments. Okay, ready?
Mark,
And
set, go. Do that again. On your mark, set, go. And then let go. I noticed that the bulb starts off, it takes a moment to get bright.
yeah, it takes like half a second, but it has to get up there, right? It has
That's
to
right.
get the brightness up there. Okay, so what we see is it takes a moment for it to reach its full brightness there.
Huh.
Okay, what is our next question? What does the ammeter needle do in the first few moments after you connect to the battery? Okay, so now
Now we're going to watch the ammeter needle.
and go. Whoa.
Do that again.
Okay, and whoa.
Whoa, it went all the way and tagged the stop and then came back. Let's try that with just one battery so that we don't have such a big...
All right.
Oh yeah, it goes way up and then comes down. And let's look at the... Okay, do that again.
Whoa.
You can see the bulb is getting brighter.
Mm-hmm. Oh yeah, definitely, right? When you charge the bulb, it actually takes a little bit longer for it to get up to speed there with that and with the brightness there.
Okay, why is that bulb glowing? You just saw the thing on resistance. You saw the video on resistance. What's happening inside that filament that's glowing when current flows through it? Well, the electrons are smacking into the particles and making them vibrate, which is thermal energy. So it makes them get hot, gets hot enough to glow. So at the very first start, when there's no current running through it, it's cold. There's no such thing as cold, but it's cold. And then you light it up and it heats up.
Giving off that light.
Now the point here is that resistance varies with temperature. If it's cold, it's not as resistance, and so the current goes way up.
At the very beginning.
Yeah. And then once it gets hot, the resistance increases and the current goes down. You ever had one of those thermometers, little digital thermometers you put in your mouth? That has a filament that runs a current through it. And as your body heat warms up the thermometer, the resistance increases, and so it reads as the temperature increases in the wire inside the thermometer until it stops changing, and then it makes a calculation and converts that resistance, the less current flowing through it, into a temperature. So
okay, so overall you're saying that at the beginning, when this separate from the thermometer thing, the filament is cold right now.
Yes.
Right, and at the beginning, when the current runs through it, it's all the way up here.
Because it's got less resistance because it's cold.
Resistance because it's cold, and then when it heats up, it settles down over here. It has more resistance because it's getting hot.
That's right.
Okay, and more resistance means less current running through it.
Yep.
Okay, and if I had my equation up there.
And if you take a moment and look at our round bulb and oblong bulb, which notice that when you had one battery, you had less resistance, and when you had two batteries, you had more resistance. And the bulb was dimmer with one battery and brighter with two batteries. So we had not as bright, not as hot, less resistance, brighter, hotter, more resistance. And that's why these aren't exactly the same, because
there was more batteries.
There's more batteries, more current, and hotter bulb, more resistance.
That makes sense. Is this making sense, you guys? And ultimately, if you're struggling here, think about this relationship, right?
Yeah.
If there's more current, less resistance, is that
that's
right? Yeah.
Well, for the same amount of voltage.
For the same amount of voltage.
Like one battery is the same amount of voltage. And so what you're saying is exactly right.
Yeah, and so just whenever you're struggling about what's going on, think back those equations, okay? All right, so for your homework today, finish, like we said, we revisit this. Finish up your the mystery bulb challenge at the very end here.
Yeah.
Make sure you calculate the resistance and the power, as well as show the flow of the electrons in the circuit.
Okay? Boom.